Hello, my name is James Halderson, and I am the lead developer and currently only developer on the Virtua-cash project that I've come up with here. I have another video that I explain in depth all the different software mechanisms that I want to work on for this project, but for today we're just going to be looking at the first software mechanism, which is the most essential for the ecosystem to exist, which is the Genesis generator. Now, what is the Genesis generator? I will give a few details here of what exactly that entails, and then we will look at how it operates in stages while I'm running this program. So the first thing I want to do here is I want to open this up, and as you can see, all that's contained in here is a blank folder for the generated notes and my test note. So if you look over here on the side, here's my Virtua-cash test note. I created this with the help of AI. I just generated this as an example, but in the long run, the actual notes may look somewhat similar to this. I might come up with some kind of characterization, use maybe the faces of certain people in the blockchain in cryptocurrency world. Got a little tongue-tied there. I'm not exactly sure what the actual images will be, but this is, for test purposes, what we're going to be using today to create some Virtua-cash. Now, before I move on and I start running the Genesis generator and everything and walk through the stages of how the digital signatures are created and stored within images, I just want to describe how this differs from another cryptocurrency out there. The main idea of the Virtua-cash cryptocurrency idea, or digital currency I should say, is that opposed to other cryptocurrencies out there in the market, all a Bitcoin is, or all an Ethereum is just numbers on a screen. It's just some value that is passed around through decentralized applications and recorded on a blockchain. But in essence, it's just a numerical value. There is no asset actually attached to that. All I have on my computer when I own a Bitcoin is I have some numerical value. The difference with Virtua-cash currency is that it's a bearer instrument traded device to device, and it uses actual imagery with encoded digital signatures within the imagery, and there's an actual asset. In this way, something actually tangibly exists, at least in a digital format, whereas other cryptocurrencies are only the numerical value representing some currency. So that's a basic rundown of what a Virtua-cash asset is. We're going to run our generator now. And let me just come over here and open this up again. And as you can see here, just want to check something. There we go. As you can see, after I opened up my prompt here, my little prompt, I can see Genesis generator restarted. No existing blockchain was found because I deleted the previous one. Create a new Genesis block. So I created a Genesis block for this blockchain, and this is the Genesis block. This new file that I have now on my computer inside of this folder is actually that blockchain. And we'll go to the notepad here. We'll use it just once. Okay. There we go. So, as we can see here, there's a blockchain now that has one block on it that just says this is the Genesis block, and it has this hash A85A whatever. The way that a blockchain works, just briefly to describe it here, is that it starts with the Genesis block, and then each block subsequent to that hashes the block before it together, and it checks to see if that's a valid hash. So if any changes are made inside of the byte data, that the byte assembly that these text files in this case are actually comprised of, the hash won't check out and the blockchain will fail to validate a new block to the blockchain. The way the Virtua-cash Genesis generator in this case here operates is that the Genesis generator has its own blockchain, which I have just started right now by starting up my Genesis generator. As notes are going to be generated through this program, blocks will be added to the same blockchain. They will take the hash and the previous hash. It'll validate that hash to make sure that nothing has changed to that underlying information, that underlying data. And if it can go back and check each hash and those are all check out, then it adds another block, it adds another block, it adds another block. So that's how the blockchain aspect of this works. But it's not just about having a localized blockchain. There's more to this than just that. The first thing that we're going to want to talk about here in our little options is that we have the generate RSA keys, type in gen keys. So I'm going to type that in. And then if you look over here on my little file explorer, you can see that after I generated these RSA keys, a new RSA key pair was generated and saved. That's our new public key and private key PAM files that we have here. We can look at what's contained in here. And as you can see, when I open up this private key, this is this massive RSA key that is being used to encrypt data. So data is encrypted with this RSA key, and then later, if you want to read that back, you can read it with this public key. The private key is used to encrypt it. The public key can be used to decrypt it by anybody that has access to the public key. So we'll open that as well, just to look at it. So that's our public key. So in theory, what would happen with the Genesis generator is that after each block is generated and an encoded message is stored within that image, which we will look at next using steganography, that after that whole process is done, you would then destroy the private key so that nobody could ever print anything ever again. It's all been printed in one go. Then you destroy the private key. The public key would therein be used in perpetuity into the future to decrypt all the digital signatures within the notes that will validate that it's a valid certificate. So that's a brief description of the private and public key. This is the JSON file. We're going to move on to the next aspect of this, describing how this operates in stages, and what that will be is the store message function. So I created this first before I made the whole Genesis generator to test this steganographic, the whole thing about encrypting a message and then storing it through steganography inside of an image and then retrieving that later using the public key to decrypt that. So we're going to test that here. We're just going to say some message. We'll say this is a test message, for instance. And if this worked correctly, we'll see here that this is a test message, was what we typed in. It stored that inside of here. It encrypted this message and stored it inside the image metadata inside of this new note that just popped up here. We decrypted it successfully to check to see if that was actually in there. It retrieved the message. This is a test message. So this note here that we see now, which is the same as the other one, but now, at least in appearance, this one contains the steganographic digital signature of this is a test message that was encrypted with this private key. So now I could give this to anybody, and if they want to validate it, if they have the other side of the application, if they have the user UI application, the wallet app, they can then use the validate function to check to see if that signature exists within that note. And if it doesn't, it's not legitimate, it's a counterfeit. But if it does contain that signature, it came from this Genesis event, and you can ensure that forever in the future as long as you have the public key. And all of the user UI variations of the application will contain that public key. So we'll continue on here. This is really cool stuff. That, just for a second alone, is a very significant thing, to be able to encrypt something, put it inside the data of something else, and then be able to retrieve it out, and it's still a valid working signature, is already a pretty big marvel in terms of working in the cryptography space. But we're going to move forward now into the Genesis, the actual Genesis event that will create a bunch of notes for us. So to do that, to move on to the next phase here, I've described these other parts. We're just going to type run Genesis. How many notes to generate? We'll say 10. Why not 10? And before I click this, we're going to come back here. We're going to see that in the generated notes, there's nothing right now. There's nothing in that folder. We're going to click, and a whole bunch of shit just happened. A whole bunch of stuff happened there. If we come back here, we can see now that generated notes contains 10 Virtua-cash assets of 500 credits, and each one of these has a unique serial number. And this serial number is then used to validate that it came from this event. Now, we can look at one block here. Actually, it'll be easier to read this if we come back up to our blockchain quickly. Let's just open this again one more time inside of Notepad just to look at it. And we can see that this JSON file of our blockchain, each one of these events here, data, a note was created, the note serial number is this, and it was made by the Genesis generator. So as these notes were created, it then added another block to the blockchain. It did the hashing function to validate the hash, and then if it was valid, created a note with a serial number, and it stored it inside of here. Each one of these notes not only has that serial number and can be validated within this blockchain, but it also contains itself a message that was encrypted using the RSA key, that RSA private key. And what each one of those says is, if I can find this here, the message inside of each one says a legitimate note was generated. Here it is. There's a lot going on here. So each one of these, just to break down the whole thing that's going on here, each one of these notes in this folder has a serial number now. This serial number is permanently recorded on this blockchain to show that it was created with this serial number, and that this came from the Genesis event. And not just that, but this message that says, wherever it went here, a legitimate note was generated here, is now stored inside of each one of these notes. So, or actually the thing that's inside of it should say, this is a legitimate note. One last thing that we can do here is that there's one more function here that says type validate. So let's type that in. And we can now enter the serial number of the note to validate the note. So let's grab a random one here. Let's take this BOV one. I'm going to say rename, if I can find that in here. I'm going to Control C. I'm not going to rename it, I just want this serial number. I'm going to come here and I'm going to Control V. I'm going to put that in there, this serial number. And message was decrypted successfully. Encrypted message retrieved here. The note is valid. Retrieved the signature. This is a legitimate note generated by the Genesis generation event. So, what's going on in that whole thing, just to run it down one more time, is that using this validate function, we can see that indeed each one of these notes, these pictures here, has a digital signature steganographically stored inside of that note that can therefore be checked whenever to show that this is a legitimate note that came from that Genesis generator event. This event that we just did here where we generated 10 of them. So, I mean, there's not much more to go into other than that. This is the first software mechanism. Basically, the idea is that, even though this is just a demonstration, is that a similar process to this would occur. And I'm also thinking about storing the serial number inside of it, but the serial number being here on the node itself and being able to be checked kind of validates already that it was, you know, created this way. But I can do that if that extra layer of security is desired. So that's this mechanism, the software mechanism of the Genesis generator, is the first thing that needs to happen. When you generate all these notes during a Genesis event, I could put 100 million in there, it'd be running for hours, but it would do this up to 100 million, which was the plan originally, is to generate 100 million in different denominations. Once those are generated, this would then all be stored. This whole folder, generated notes, then goes up into the cloud somewhere on a website, and I would just build some JavaScript front-end facing app to trade something for the notes. I'm not exactly sure how that's going to work yet. I'm still thinking about that, but the idea is that it's a decentralized, away from the bank's currency, that can actually be traded device to device. And the way to make sure that all these things are valid is this steganographic digital signature workflow. So that's about it for this whole thing. I just wanted to demonstrate this. One last thing I should go into is that there is, how many lines of code here? There's almost 500 lines of code in this part. If I go to the rest of my solution explorer, there's these different, the AES encryption, which I'm not using for this part. I used RSA for this part. Blocks, blockchain, block data, and the main program. If you watch this video and you're interested and you want to know more, feel free to ask me. I can make more videos on the actual code and how these different, how all this functions. This is all written in C# right now. There's a lot to go through, but I don't want to make a video specifically right now on the actual code itself, but I could in the future. So that's the devlog for part 1, completing the Genesis generator. At least this is a proof of concept for the Genesis generator. Again, contact me if you have any questions. Ask in the comments on YouTube or on Facebook, or I might post these on LinkedIn. I'm not sure. I'm just going to keep working on this in the future, and if anybody's interested, you want to know more, or anything, feel free to contact me. Thank you for watching my video. That's about it for today. Bye.